many people say, garbage collectors are bad, and I thought, is it because of the way they think about code, or is it because of the kinds of programs they have to write? It's so. For instance, to me, thinking about, say, if I had to write a compiler, and if I have to write it without garbage collection, it feels like I will have to think so much harder about data structures, their lifetimes, and it will force me to freeze my design, probably because changes that would change the lifetime of things may be difficult. So it feels like I just, it seems some problems are just so much harder when you have to think about manual memory management. Yeah, that I don't understand.
I would agree with you because in the sense, but you're taking a very rational approach. My guess, why are people so afraid of garbage collectors in some circles is that they have a total misunderstanding of what the actual cost is. One of the questions I ask when I have new hires is talking about the same system, doing pretty much the same thing in C++, C or C++, and say Java on the other hand. There is a cost in performance. What will that cost be? Experimentally, I mean, we've seen systems where the actual difference in performance was somewhere between like 30 and 70%. I mean, a factor 1.3 or factor 1.7, not even a factor 2. So that's the reality I've observed. And people fantasize, with the garbage collector, it must be at least, let's say, 10 times slower. Well, the real cost of a garbage collector is nowhere close to that. A, because they are amazingly optimized beasts nowadays. And B, because if you don't have a garbage collector, you have to replace it with manual memory management, which has also a cost. It doesn't come for free either. And now just talking about performance, and you're totally right, performance should not be the main topic of the conversation here. The topic of the conversation be, can you actually pull it off? Can you actually write something this complex without a garbage collector with the impact on your data structures? But even if you look only at performance, I think people have a lot of fantasies about the real cost of what a garbage collector.
And a lot of misunderstanding is about the costs of not having one, which
Absolutely.
come in terms of development time, but also in terms of performance. Unlucky malloc implementation, all those frees. I mean, it has costs too, and yeah, I mean it's my experience with Rust, where I ended up copying stuff, which also has costs. So it's not it's not as clear cut as what at least some people believe, but I think the biggest challenge for collectors is if you have unpredictable poses. And I think that's, if that matters for your application, I think that's one thing where, if you don't really know when the collector is going to fire, that's an issue. So when I was doing real-time garbage collection a while back, I went to see a company that was headquartered in Chicago, and they were doing high-frequency trading. So, all of that, they're the leech on our system, sucking blood. Not necessarily a good thing, but they were doing it in Java, so it was interesting to talk to them. And what they were saying is, we're sort of very afraid of poses, so we run single core, and we size our algorithms and our memory so that the system can run for 8 hours without having a full garbage collection. And why 8 hours? Because that's the 9 to 5 cycles of, and then they just kill the box and restart. So I thought, okay, that's another way to deal with that problem. You sort of just don't garbage collect for your time.
In fact, it's not even that you don't garbage collect. You control your own dynamic allocations to avoid garbage collection altogether, which is a strategy, but it defeats the purpose to some degree, I
So
would say.
they were allowed in themselves the small the young generation GCs, but not the full. In their case, they were running on a JVM, and it was we're talking that was 15 years ago. So technology has improved since, but it was amusing how much effort they went around, and why Java, because they could hire a developer cheaper, and the costs were less, and it was easier to change the algorithms. So they felt like, yes, it's complicated, but we can have developers that can write new algorithms cheaper and faster than if we were doing C.
Yeah, I can imagine. I really can imagine people making these kind of calls.
So is parsing a solved problem? Are parser generator the answer? Or should there be more work, or should we just buckle up and write them by hand?
That's an interesting question. It is a solved problem. I mean, we know how to write parsers. At worst, we can write parsers manually. Many production level compilers use manually written parsers for tons of good or bad reasons. Performance being one, error recovery and error reporting being another one sometimes, just cluelessness, or fear of what the performance implication of parser generation could be. It is a solved problem. Now, there's no. I think it's a solved problem today. Who was that? I think it is Niklas Wirth who once said there is no point in designing a language which is not LL1 nowadays, and I fully agree. If you are to design a language from scratch today, making it easy to parse so that parser generators can be used and deliver consistent performance and good features, and you definitely should. There's no. I think you should. It's one of the best investments you can make in your language to make it easy to parse, as opposed to languages that are notoriously hard to parse. C++, for instance. There's a preprocessor that makes it a mess, and then the mix between semantic analysis, the type def issue of C++ makes parsing C++ crazy complicated. And I think that is a real industrial hurdle in this. So making languages easy to parse is definitely a good idea. But the statement of Wirth was absolutely relevant, but misses one point, is that this statement was made 30 or 40 years after the first language for design, and needless to say, all the languages are not LL anything. They are like idiotically poorly designed at all levels, and all levels start with lexical and syntactical level. And it's funny that you mention, parser generators, because one of the things that we at Raincoat did, and it's a design decision, so I'm not saying it's the only way to do this, but we decided very early in the process that when dealing with very complicated languages like COBOL and PL1, parsing them manually would be a total waste of time. Parsing PL1 manually, I'm not going to say it's impossible, but it's freakingly complicated. It raises tons of complicated issues. Besides, bear in mind that we don't just parse PL1, we parse PL1 with embedded SQL and with embedded CRCS statements, so we just compound the problems, and it's getting pretty much intractable if it had to be done manually. So we accept the performance penalty of parser generators. At the end of the day, the performance penalty is nowhere as bad as it used to be. Nowadays, machines are what they are. It doesn't really matter this much. And it gives us a great level of versatility when it comes to performing syntactical analyses. And even so, so these are generated parsers, so that, in theory, they should deal with everything for us. In practice, we have to tweak the parsers, use the hooks to control the way it's going to backtrack or not backtrack depending on circumstances, because the languages, I'm talking for both PL1 and COBOL, are so poorly designed that it's super hard to parse otherwise. I only know of one other COBOL compiler which uses a parser generator. As far as I know, for what it's worth, and it's not as if I had, let's say, a complete study of the field, but as far as I know, these ours and this other compiler are the only one that use a parser generator. And even the one that uses a parser generator uses Yak. And because Yak has tons of limitations that makes it dramatically unsuitable to actually process COBOL adequately, there is a pass that scans the COBOL source code and that inserts specific lexical hints, such a way that the parser can then synchronize on those and parse it adequately, because otherwise the language is too ambiguous. It is a solved problem, but the legacy is really killing us.
That's interesting. So I've heard several folks working on their languages saying, oh yeah, we wrote it by hand, it's just much better. That's interesting. But I completely agree with you on the complexity of the language. One should design languages that are easy to process. I think, if you look at how much work was done around Lisp, which was the simplest language to process. Then when Java came out, the first one of the big advantages was you could forget the syntax and work at the bytecode level. And that enabled a lot of research to happen because, you could forget the parsing bits. And I always thought that, relatively speaking, Scala and C++, just to pick on two of those two, had fewer research and tools and things around them. And my theory was always, they're so complicated languages that it's much harder to attach tooling around them. It's just, and yeah.
I fully agree. I wouldn't be able to elaborate on Scala, which is not really my domain. But on C++, you're 100% right, because C++ is designed in such a way that you basically cannot reliably analyze it without analyzing thoroughly. You cannot do something superficial in any reliable way because there are too many things that could happen. And that's even before considering the preprocessor that can screw up things even worse. So no, I fully appreciate that. Some languages have not had the level of research they could have had just because they are needlessly hard to analyze. I really, and on the opposite end of the spectrum, the fact that Pascal was easy to parse and easy to compile was, I think, one of the major factors to its success. When I first met with people working on compilers in college, I remember them saying me something that really stuck with me, saying writing a simple Pascal compiler is 6 months worth of work. It's not that hard, simple. They even said simplistic, simplistic Pascal compiler is not that hard. Writing anything that starts to optimize Pascal, anything is like you're going to talk in multiple years. That's where the gap is. And back to your point, it's 6 months because, among other things, syntax is straightforward.
Most languages today, keep growing, and they sort of start simple and they become, bloated monsters. And, so one wonders if by by adding features, losing simplicity, it'll be much harder for somebody to work with today's Java than it was to work with the Java of 20 years ago. It's a better language, but it's more complex. It's more, and we seem to be pushing things towards that complex side of the world. My fear is that it will make building tools, doing research harder, right? The price of entry will become much steeper. Back 20 years ago, doing an extension for Java was a very simple thing, and you could have a couple of students and do that in a year, and you would have a paper. And now to touch Java in any way would probably scare me.